Now we're going to look into polynomial operations. So to start with, we're going to look at what a polynomial is. We name them based on their number of terms. So if it has one term, it's a monomial. So for example, a polynomial like 4x squared. That only has one term. There's nothing being added or subtracted from it, so that's a monomial. Two terms is a binomial, so you might have 3x plus 4. That's a binomial. Three terms is a trinomial, so you might have x squared minus 4x plus 4. And then if there's 4 or more terms, we just stop and call it a polynomial. So you might have 3x cubed minus 2x squared plus 5x minus 6. And those are just examples. Okay, the exponent doesn't matter. It can be any exponent anywhere. So I could have another monomial that is 10x to the 15th. That's still a monomial because it only has one term. You also name polynomials based on their exponent. So if it's no exponent, no variable at all, like 5, that's just a constant. A first-degree polynomial would have a leading coefficient of x, or x to the first power. So something like 3x plus 2. There aren't any other exponents higher than that 1, so that's a first-degree polynomial. A second degree would have an x squared. So the example we used above, x squared minus 4x plus 4, that would be a second-degree polynomial, and so on. So whatever your leading exponent is, your highest exponent, that's how you're going to name it by degree. We're going to focus mostly on naming them based on how many terms they have, whether it's a monomial, binomial, trinomial, or just a polynomial. So adding and subtracting polynomials. You need to combine your like terms, right? Your like terms have the same base and same exponent, and a red flag should always come up anytime there's subtraction before parentheses. Because if there's a minus out front, that's really a -1, and you've got to distribute the -1. So for example, if you had 2x minus, and then in parentheses, x plus 1, you're not just subtracting x, you're subtracting this entire quantity, x plus 1. So you're going to have to distribute that negative, and then it becomes 2x minus x minus 1, and 2x minus x is x, so my answer is x minus 1. Okay, always look for that red flag. So a couple of examples. For the one on the left, we've got addition. If you have addition to parentheses, they don't matter. You're just adding and combining your like terms. So I have a k to the 4th and a k to the 4th. So -4 and -3 gives me -7, and I'm going to keep the k to the 4th. Then I have a 14 and a -8. 14 minus 8 is positive 6. And I have a 3k squared and a -14k squared to get -11 k squared. Okay, a rule of thumb, you always write your polynomials in descending order of their exponents. So my highest exponent is k to the 4th, so I'm going to put that term first. Then I have k squared, so I'm going to put -11k squared, and then my constant doesn't even have a variable or an exponent, so plus 6. For the example to the right, we have subtraction, so this is really a -1, so before I do anything, I've got to distribute that -1. The first set of parentheses doesn't change, so I have 8n minus 3n to the 4th plus 10n squared, and then this parentheses becomes -3n squared minus 11n to the 4th plus 7. Right, I multiplied everything by a -1, so I had to change all of the signs. Then I'm just going to combine like terms. I have 8n and no other n's, so I'm just going to bring that one down. I have an n to the 4th and a -11n to the 4th, and that's going to give me -14n to the 4th. I have a 10n squared and a -3n squared. It's going to give me a 7n squared. And then I have this 7 out here by itself with no match, so it's going to be plus 7. Again, you want to put your exponents in descending order, so I've got an n to the 4th, so -14n to the 4th, then an n squared, then an 8n, and then the 7, and that's my answer. Multiplying polynomials. We have two methods. I don't care which method you use, but I want you to become a pro at one of these methods. They always work, so make sure that whichever one you like best, get really, really good at it so you can do it every time. Okay, the first one is FOIL, and the second one is a box method. Okay, there's always this distribution property, so if it's just a monomial times something or a monomial times a monomial, typical multiplication rules apply. But if it's more, if it's a binomial or bigger times another binomial or bigger, we're going to use FOIL or the box. So FOIL stands for first, outer, inner, last, and that's talking about the terms in your binomials. So if I have a binomial and I have x plus y times a plus b, the first two terms would be x and a, the outer two would be x and b, inner y and a, and last y and b. So you multiply, then you would combine all of your like terms. The box method, we're finding the area of a box. So to find the area of a box or a square, you do length times width. So you're going to make your box, and if it's a binomial times a binomial, that's two terms each, so it's going to be a 2 by 2 box. And you're going to put your binomials across the top and the bottom. So for this one, we have x and y, a and b. Then you would multiply to find the area of each square. It's weird without actual numbers, so we'll look at examples in a minute. But both of these examples have two binomials. They work for any polynomial multiplication that you do. Okay? So for our first example, I have a monomial times a binomial. So I'm just going to distribute. That 6v has to go to everything inside my parentheses. 6v times 2v is 12v squared. And 6v times 3 is 18v. I can't combine any like terms, so I'm just going to leave it like that. The second one is a binomial times a binomial. So this one I'm going to do by foiling. Okay, again, you don't have to do both. Pick either FOIL or the box method and do it every single time. So first, 4n and 2n. Well, 4n times 2n is 8n squared. Then outer, 4n and 6. 4n times 6 is 24n. Inner, 1 times 2n, 2n. And last, 1 times 6, 6. My only like terms are the 24n and the 2n. So then I get 8n squared plus 26n plus 6. And that's as far as I can go to simplify. So here's another example, but now for this binomial times binomial, I'm going to do the box method. Okay, it's two terms in each, so I'm going to do a 2 by 2 box. And it doesn't matter if I put the 6p plus 8 on the top or on the bottom, or down the side, doesn't matter. I'm going to put it across the top. So I have a 6p and then plus 8, so this is a positive 8. Going down the side, I have 5p, and then this one's minus 8, so that's a negative 8 that I'm going to write down the side. Then I'm going to find the area. So I'm going to break it up into these 4 boxes. To find the area of this box, I've got to do 5p times 6p, and so that's 30p squared. This box is 5p times 8, and that's 40p. This box down here is 8 times negative 8, it's negative 64. And then this bottom left box is negative 8 times 6p, so that's negative 48p. So now I found the area of each of these individual boxes. So to find the area of the whole thing, I'm just going to add them all up. So I have 30p squared plus 40p minus 48p minus 64. I have like terms at 40 and negative 48p. So when I combine those, we get 30p squared minus 8p minus 64. If you notice, you have like terms diagonally. Sometimes, in some cases, not as common, you won't have any like terms, but if you do, they're always going to be diagonal. So you could skip this step of writing them all out and combine them when you write your final answer. Then for this last one, I'm going to do the box again. Or we have one more after this. I'm going to do FOIL and box one more time. But now I have a binomial times a trinomial. So I have two terms times 3 terms. So my box needs to be 2 by 3. So it's just going to make it a little longer. But I'm going to do everything else the same. Now 4a plus 2 has to go down the side because this is where my 2 terms are. So I have 4a and a positive 2. And then my trinomial, I have 6a squared, a negative a, and a positive 2. My top left box, 4a times 6a squared, be 24a cubed. 4a times negative a, negative 4a squared. And 4a times 2 is 8a. Now I'm going to do the same thing across the bottom. 2 times 6a squared is 12a squared. 2 times negative a is negative 2a. And 2 times 2 is 4. So now I'm going to look for my like terms. I have two sets. I have this diagonal with a squared, this diagonal with a, and then a cubed and a 4 by themselves. I'm just going to bring everything down. I have 24a cubed, and then 12 and negative 4 gives me a positive 8a squared. Negative 2 plus 8 is a positive 6a, and then my plus 4. And that's it. And for our last example, I have a trinomial times a trinomial. I'm going to use the FOIL method, but instead of having first, outer, inner, last, I'm just going to look at it as this term has to be multiplied by everything in my other parentheses, because I have more than just the 4 terms for FOIL. So I'm going to take 6n squared times 7n squared. That gives me 42n to the 4th. Then I got to do 6n squared times 6n. Gives me 36n cubed. And then 6n squared times negative 5. Negative 30n squared. Now I'm going to do it all again, but with the negative 6n. So I've got negative 6n times 7n to get negative 42n cubed. Negative 6n times 6n to get negative 36n squared. Negative 6n times negative 5 to get positive 30n. And one more time with my negative 5. So I have negative 5 times 7n squared. I'm just going to come down to a second line because I'm running out of room. So I have negative 35n squared, negative 5 times 6n to get negative 30n, and negative 5 times negative 5 to get a positive 25. Now I have one super long polynomial that I'm going to combine by like terms. So I don't have any other n to the 4th, so 42n to the 4th. I have a 36n cubed and a negative 42n cubed. So I have, what is that, negative 6n cubed. And I have negative 30n squared, negative 36n squared, and negative 35n squared. So that is negative 101n squared, I believe. And I have a 30n and a negative 30n, which actually cancel out to 0. And then I have plus 25. Okay, so FOIL is the same idea, but now because I have extra terms, I just take everything from my first parenthesis and multiply by everything in the second parenthesis.